Dear students, greetings to all. In previous video, I have discussed about the carbon ions, and today stability order of carbon ions. I am going to discuss carbon ion in which carbon carries negative charge. So carbon carries negative charge is electron rich species. If any atom which carries a negative charge, that is the electron rich species. Okay. Now in carbon ion, carbon carries negative charge. What does it mean? So it is already electron rich, so it doesn't require any electron. If electron donating groups increases on the carbon ion, the stability decreases, because carbon in carbon ion is already rich in electrons, so that it doesn't require electron. If electron withdrawing groups, that means any electron intake atoms or groups attached to the carbon ion, stability increases, because carbon can give electron now, so that number of donating groups increases on the carbon ion, stability decreases. Number of electron withdrawing groups or atoms attached to the carbon ion, stability increases. So here the stability order, methyl carbon ion is more stable than the primary carbon ion. Primary carbon ion is more stable than the secondary carbon ion. Secondary carbon ion is more stable than the tertiary carbon ion. So what is the reason? Because carbon carries negative charge, so that it is electron rich. So the stability increases when electron withdrawing group is attached to the carbon ion. Stability decreases when electron donating group attached to the carbon ion. So primary, secondary, tertiary. Okay, this is the stability order of carbon ions. Now another reactive intermediate is free radical. Free radicals. So free radicals also reactive intermediate. How it can be generated? It can be generated through homolytic cleavage. So homolytic cleavage is nothing but the bonded electrons is shared by two bonded atoms equally. So for example, we take like Rx, if when it is undergo at homolytic cleavage under H nu. So what happens here? Two electrons are there in the bond. These two electrons which is shared by these two atoms R and X. So when homolytic cleavage, when it is undergoing, the arrow shown as a half-headed arrow or fish hook arrow. So in this case, both atoms get one odd electron. So any atom which is carrying odd electron is called as a free radical, So free radical can be generated through homolytic cleavage. Free radicals. So this is the free radical, and structure of free radical, so which is similar to the carbonium ion or carbocation, because carbon in valence electrons are 2s1 2p3, in that 2s1 2p3, in that 3 electrons undergoes the hybridization to give that sp2 hybridized orbital. These sp2 hybridized orbitals form the bond with the 3 hydrogen atoms in the methyl radical. So this is the structure of free radical. In this, one unhybridized orbital will be there. so that carries that odd electron. So this is the planar structure and planar structure and 120-degree bond angle. Okay, stability order which is similar to the carbocation, because there is a electron deficiency in the free radical, so that tertiary radicals are more stable here. Tertiary free radicals are more stable here than the secondary radicals. Secondary radicals are more stable than the primary radical. Okay, primary radical is more stable than the methyl radical. So this is the primary, secondary and tertiary. So this is about the free radicals. I hope you understood. If you like, share, subscribe, then only I can make many videos. Thank you.